It's always my suggestion for you to go read the things in your notes, but for sake of time, I'll just jump in and remind you of a few things. If this were an equal sign, it would be a perfect slope-intercept form, and it would have an intercept of 6 with a slope of -2. Remember, a slope of -2 is a down 2, right 1, or an up 2, left 1. So we would begin by putting as many control points as we could, and we would do this so that we could create as accurate a graph as possible. And after we get to the right-hand border of our graph, we would go back and go left. So as we go left, we go up to left 1. And once we've reached the border of the graph, then we will stop and draw the points. So when we draw the points, we're not going to draw a solid line. And here's the reason why, and it should be rather obvious. The big three things that we're supposed to remember in algebra are simplify, solve, and graph. So remember that a solution, when you solve, makes true. And remember that a graph is a plot of solutions. So let's just look at one particular point. And the point that let's look at is that y-intercept point of 0, 6. So question, is 0, 6 a solution? So let's try it. Let's put in a y value of 6, an x value of 0, and ask, is 6 greater than 6, yes or no? And the answer is no. 6 is not greater than 6. 6 is equal to 6, but it's not greater than 6. So are all of these control points that we just plotted, are they solution points? And the answer is no. You could test any one of them the same way we tested 0, 6, and you would see none of them are solution points. So what I'm going to do then, when I draw my line, I am not going to draw a solid line. Instead, what I'm going to do is to draw that as a dotted line. So I'll just draw little blank spaces, and again, it's just so hard to draw these lines. Oh, this is so hard, and I'm even using a straight edge. Now, it turns out, though, that on one side or the other of this dotted line is where I find solution points. So would I find solution points on the left side or on the right side? Sorry, I said that completely backwards. Would I find solution points above that line or below that line? And that's where these statements up here come into play. Specifically though, if I pick any point on my graph that I've plotted over here, it's a point of equality, but I want the y value to be bigger than the point that's on the graph, or that's on the line. So I want my y value to be bigger than, and y gets bigger as I shade above. So I'm going to take all the region that's above this line, and I'm going to shade it. Now, typically what I like to do is I like to test points. So I'm going to test 0, 0. And the way that I test a point is I simply substitute the x value and the y value into the statement and see if it becomes a true statement. So is 0 greater than 6? And the answer is no. So do you see 0, 0 on this graph being shaded? And the answer is no. If I wanted to, just optional, I could pick any point that's in the shaded region. So I think I'll pick x value 0, y value 10. So if I test 0, 10, then 10 is the y value, 0 is the x value, and so is 10 greater than 6? And it is. So the side that holds 0, 10 should be shaded. The side that holds 0, 0 should not be shaded. So that's one way to figure that out. And again, that's why I'd suggest you always want to read the notes just because they have some mention of principle and guidelines to you. From the last lesson that we did, this is a standard form equation. In inequality, we always start out as if we're graphing an equal sign. So let's build that little table for standard form equations. Let's use a 0 for x, and let's pretend that we're doing equality. So let's see this as being 2 times 0 minus 3y is equal to negative 6. And if we divide both sides by the negative 3, we'd get a y value of 2. Now, let's try a y value of 0. So 2x minus 3 times the y value of 0 equals negative 6. Let's divide both sides by 2, and we get a negative 3. Let's plot those points at 0, 2, the y-intercept, at negative 3, 0, the x-intercept. And then we see quickly that that's a 2/3 slope, rise 2, run 3. So let's continue that pattern, rise 2, run 3, rise 2, run 3. And let's do that pattern all the way across the graph. And then let's go the other way, drop 2 and go left 3. Drop another 2, go left another 3. And then when we've gone all the way across the graph, we'll see that we've gone from border to border. Always go from border to border on your graphs. Now, should I use solid or dotted? Now, the things at the top just say if it's got an equal sign, you should use a solid line. But remember that a graph is a plot of solutions. So let's just ask a simple question. Is 0, 2, actually, let's don't test 0, 2. Let's test this point over here, this second point away. That's 3, 4. Is 3, 4 a solution? So the way that we test to see if it's a solution is we take the form of the structure and we substitute. So we have 2 times 3 minus 3 times 4. Is that greater than or equal to negative 6? Well, that would be 6 take away 12 greater than or equal to negative 6. So is negative 6 greater than or equal to negative 6? Yes. It's not greater than, but it's equal to. And so that's what tells me that every one of these control points that I plotted as I was doing my rise 2, run 3 is a solution point, and therefore the line is a solution. And if the line is a solution, that means that I should use a solid line as I draw. So I'll lay my straight edge on there and then hope for the best as I do this. I hope that I can draw a reasonably solid straight line. Well, reasonably. So the next thing I have to decide is which side needs to be shaded. So if I test one side or the other, and I always prefer to test 0, 0 just for ease. So if I test 0, 0, then it would be 2 times 0 minus 3 times 0 greater than or equal to negative 6. So all of this works out to 0. Is 0 greater than or equal to negative 6? Now think about it. Is 0 bigger than negative 6? And 0 is bigger than negative 6. So that's what tells me that this side here that holds 0, 0, the part that's below the line, is the solution area. Now, one of the other options that I have, and I think that I'll change colors just to try to emphasize that. One of the other options that I always have is to put this into its y-equal form. So let's do this as a little optional approach. if I had 2x minus 3y greater than or equal to negative 6, then I could subtract 2x across and have negative 3y greater than or equal to negative 2x minus 6. And then I could divide both sides by the negative 3. And as I divided both sides by the negative 3, then I would have to reduce these fractions. And it would reduce down to a y here. This would be a positive 2/3 x, and this would be a plus 2. But when I divide an inequality by a negative, it always switches the sense of the inequality. So we'll talk about that more specifically in class, but that's a rule that you should remember from your Algebra 1. So this would then become not a greater than, but a less than inequality. If I do it that way, that's fine. It doesn't take a particular lot of steps. But notice that when I do that, that would give me an intercept of 2, and that's what I see over here on my graph, a slope of 2/3, and that's what I already knew when I graphed it the first time. But now it says y less than. So how does y get less? How does y get smaller? Y gets smaller by going down. So I'm supposed to shade what is below the line that I've graphed. So here's another standard form equation. So this time, maybe we just want to go to the y equal mx plus b form. Let's subtract the 3x across, and this will just be good practice of paying attention to those signs. So the 3x got subtracted to make it disappear from the left. So it shows up on the right. It shows up on the right as a negative. And now I'm supposed to divide everything by the multiplier of y. Notice that that's an inverse. And then simplify everything that I see. So y is going to be, oh dear, I told you all about that last time and then missed it myself. When I divide by a negative, it switches the sense of the inequality. And the 8 divided by the negative 2 is a negative 4. That would give me a negative 4 for my intercept point with a 3/2 slope, rise 3, run 2, and continue that rise 3, run 2 pattern until you get all the way across the graph. So as soon as you've gone all the way across the graph, then go back to the intercept point and go down 3, left 2, and then decide, should I draw that as a solid line or as a dotted line? And because it simply says less than, not less than or equal to, then I should draw that as a dotted line. Now, after you've drawn that dotted line, you have to decide which side to shade on. Now, the less than inequality here tells me that I should shade below. But I'm still going to test 0, 0 just because it's never very hard. And I'm going to go back to the original statement of 3x minus 2y is greater than 8. So is 0 greater than 8? And the answer is no. And that's extra confirmation that I should be shading this region here. So 0, 0 is not in the region that has solution points. And also, the y less than indicates I should shade below. Now, if you forget to switch the sign of this inequality right here, then that test of testing 0, 0 would catch that you had a mistake. So it's always a good idea to test that 0, 0 point. So 2 last quick ones. Remember from the last lesson that an x equal line is a constant x value. So this has a constant x value. And the x value never changes, and the x value is always negative 3. And I should use a solid line. So I am going to draw a solid line down that grid line at x value -3. And that's a vertical line. After I've drawn this x value -3, then I have to decide how to shade it. So should I shade on the left side or should I shade on the right side? And again, there are two ways to do it. How does x get greater on the number line? And the answer is to the right. But let's test 0, 0 just to see what happens. So take out x and put in 0. You should also take out y and put in 0, but there's no substitution for y because there's no mention of y. This is a constant x value. So question, is 0 greater than -3? And the answer is yes. And so the side that contains 0, 0 is the side with solution points. So that would be to the right, but notice that as I read it, it simply reads x is greater than or equal to -3. So all the points along this vertical line at -3 are the equal to -3, and the shaded region is all the points where the x value is greater than -3. Here's another simple thing. Just put a dot somewhere and ask yourself, is this x value greater than -3, yes or no? So pick another point somewhere and just ask that same question. Is the x value of this point greater than -3? And you'll see the answer is always going to be yes. This last problem has a statement about y, so we should always get the y to stand alone. Let's divide both sides by -7. As we do, you have to take careful note to see that dividing by a negative changes the sense of our inequality, so the greater than becomes a less. 21 divided by a -7 is a -3. So in this case, notice there's no reference to x, and anytime that you see something like this, this has a constant y value. And the first thing that we should look at for our graph is just the graph of y is equal to 3. And here's a simple way that you can test a constant line, either x equal or y equal. Go to the appropriate axis, in this case y, put your pencil at the appropriate value, in this case, whoops, sorry, not 3, but -3, and then ask yourself, if I move my pencil up, would I still be at y value -3, yes or no? And the answer here would be no. So ask your question, what if I move my pencil down? Would my pencil still be at a y value of -3? And again, the answer is no. Now move your pencil to the right and ask yourself, is the y value of my pencil still -3? And the answer is yes. So no matter how far I move that pencil left or right along that grid line at -3, the y value is a -3. So that's how I decide how to draw the horizontal line. But now the real question is, where do I find y values that are less than -3? And y gets less as I go down. And so I'm going to shade everything underneath the constant line at y equal -3. One last thing that I could do, and I never write this, I just do it in my head real quickly. I always test 0, 0. And this is my y value here, the second 0. And so I'm going to take the y value and substitute it into my original statement, and it simply becomes -7 times 0 greater than or equal to 21. So the question then, multiply, is 0 greater than or equal to 21? And the answer is no. So that tells me that the solution points are not on the side of this line that contains 0, 0. It must be on the other side of the line. So those are a couple of last little reminders to you on how to graph horizontal vertical lines where there's only either an x or a y value, but not both. And whether you want to read the inequality symbol as being above, below, left, or right, or whether you want to test any point on either side of that line to decide the solution region, Those are always valid options.